All right, let's get started building the kit here real quick. For those of you that don't know, this has been in the works for quite some time. It's loosely based on one of our robots we've been fighting for a couple years that's never been knocked out, called Skylift. It's a very durable flipper robot. People have asked me for a version of that for a period of time, and it's actually my son's robot, and he wanted some spinner modules for his flipper. So I decided, let's do it. So the past probably 6 to 9 months, we spent a lot of time developing a modular, easy to build, and very durable kit that's on par with the current level of competitiveness in 1-pound combat robotics. What you see here is the lifter. You have the horizontal, and you have the vertical. Now all of these can change from one to the other in 10 to 20 minutes between rounds. So for example, say you had the lifter and you get the lid off, all you have to do is get the top piece out here, the front that is, and as it comes out, you can set it aside, grab the front end for your new module. In this case, it's the module for the horizontal. Pop in your new front end, pop in whatever you need to change, your weapon module or anything else, put the lid on, and go. It's that easy. We're going to start with building the base kit right now. All of them have the same drivetrain, the same inner body, the same base plate, so that they're easy to swap and easy to keep spares for. So let's go ahead and get started. All right, when you start, you have your base plate, you have your inner body, you have your tires, which we'll set aside for now. These are the optional wheel guards that has the hardware and the wheel guards in there. And this is the main guts of the basic part of the kit. So you've got your wheel hubs, your charge jack. The kit also accepts a fingertech mini switch if you prefer the screw switch style. It mounts right here. You can see it on the flipper right here. That's where the mini switch mount is. There's screw holes right there. You can thread it right in. I also take a 2S battery, a 3S battery, and I know the two spinners will take a 9-volt. The lifter, I'm pretty sure it can fit as well. I haven't really put it in yet. But anyhow, on to building it. So you have your charge jack, that's the way it comes stock. You have your bag of tools if you need any tools. These are lever clamps. They're used to connect all the power together. These are a bag of drive mounts and hardware, a drive speed controller, drive motors, and then the various hardware to assemble everything. So let's go ahead and get started. First thing you're going to want to do is empty out this bag right here. You're not going to need all of it right away because part of it goes with the add-ons, which we'll do later in the video. So we can put away 2 of these standoffs here, and we can put away 2 of the 1/4-inch screws, as well as all of the top screws, which are 3/8. So that can set aside. We're also going to do our drive mounts right here, which includes a carbon fiber plates and then 4 each screws to mount them with. You're going to take your inner body, take one of your drive mounts. I find it easiest if I put the screw on the screwdriver first, kind of hold it with pressure on there, find one of the holes on the side, and then get it going. Once you get one going, then you're good. You can kind of see that's how it goes right there. It's pretty easy. These are made to thread into plastic, so they go in the body pretty easy and they hold on pretty good. There you have it. You have your drive mounts on both sides. Now we can move on to putting them on the main body. Drive mounts. So on the main body, you're going to have a 1 offset hole. These mounting holes in here are for the various weapon modules, and then this hole here is for the charge jack. You want to keep this on the left-hand side of the body. So you want to take your standoffs, put them in the rear, and grab an appropriate driver, flip it over, get one of them lined up, and pop it in. Then do the other two. Alright, now you are ready to put in your charge jack right here. If you're doing the mini switch, it's the same as every mini switch. You screw it in right here and solder it up. But for the mostly beginner people, the charge jack's a very easy way to do things. No soldering required to put one of these in. So you take the plug out of it. That's for later. And there's a little thing here called a jack nut. This thing that spins off. If you can see it better if I bring it up here. So once you get that off, you set it aside. This mounts into the chassis and that hole we just discussed, like so, if you can see it there. And then you take the jack nut on the bottom and just kind of screw it on. Now I like to take a pair of pliers, like needle nose, like this, and give it a little bit of tightening. You don't want to go crazy on it and strip it, but you do want it snug so it doesn't come off in the middle of a fight. There you have it. Your charge jack is now installed. We can leave this jack or this plug out until we get to the point of actually powering the robot. Next thing you want to do is put in your drive motors. In the drive motor bag, you will find the drive mounting screws. Now we include 5 screws in case you lose one because they're very small. So you only need 4 of them. Now when you mount them, you need to look at the orientation. The one on the left side of the robot goes in flat, like so. You can see it like that. And the one on the right hand side goes in vertical, like this. And that's to accommodate the battery and the receiver in a later step. So the way the screws go on these motors, they align with the flat part. So if you're putting in the sideways one, the screw holes are going to be on the side. So you pop it through, like that. Grab a screw. And just kind of thread it in. When it gets tight, you're good. There you go. We'll do the other side. I'm left-handed, so I use the driver with my left hand most of the time. You may do a mirror version of this if you're right-handed. Alright, there you have it. Your drive motors are mounted. Now we can move on to the drive speed controller. This is a 2-channel speed controller. So it controls both wheels in one unit. It's very handy, it saves space, it's also very light. These 2 ends are going to go into your receiver, which we will do at a later step after we do the weapon add-ons. This is your power wire right here. It's called an XT30 connector. You could cut these off and strip the wires back, but we found if you just plug in another XT30 pigtail, it becomes a lot easier to use because you have more length and more flexibility placing it inside the robot. So now that we have this ready, we're going to go ahead and use the lever clamps to start the power distribution. On your charge jack, you have a red lead and a black lead. The red lead I put in the first port on your positive one, and then the black will be the negative one. See if we can zoom in a little bit here, make it easier. Alright, now this, since it has the red wire, this will be all your plus wires or positives will go to here. Same for the black, will be all the negatives or grounds. So you pop in red wire here, black wire here. And that's pretty much it for this part of building the main body. It doesn't take very long. the next step you would do is put on the wheels. I tend to not do it until the end, but I'll show you how to mount them. These are called twist hubs. So the way they work is you twist, you take this little ring, you push down on the foam, and it compresses it, and you twist it, and it locks in these little spots here. And that keeps it from falling off while you're in a fight. And then it's held onto the shaft of the motor with this little set screw right here, like so. So you want to back that off before you start. What I like to do is put the wheels on first. So you take one like this, pop it on, give it a good squeeze, see it pops out like that. And you see right here, these little holes right there, if you can see them. That's for the twist key, which is part of your tool set. It's this item. This lines up with the two notches. Then you can just push down and twist. There you have it. It's on. Now the way I like to put them on the robot is, if you look at the back, you'll see a little square dot. That's where the set screw is. So you can take your wrench and just tuck it back there until it catches. There you go, it's caught. And so you'll go onto the robot right here, slide it on the shaft, make sure the flat part is up where the set screw goes, tighten it down, there you go, you're good to go. You'll also need to solder the leads on these motors. So the way this goes is there's two pairs of motor leads on this speed controller. I call this one the inner pair because it's on the inside, and I call this the outer pair, it's on the outside. So what you want to do for the inner pair, you want to take the red wire and go to the positive side of your left-hand motor. For the black wire of the inner pair, it goes to the negative side of your left-hand motor. The outer pair right here, this one, you reverse the polarity. So the black wire goes to the positive lead on your right-hand motor, and the red wire will go to the negative lead on the right-hand motor. And that has to do with the mixing and the drive of the robot, which will be addressed later when we do the receiver. That about covers it for this portion. So we'll move on to one of the add-ons in just a second. See you in a minute. So through the magic of TV, we are back, and these motors are now already soldered. Saved you the time of having me do it while we're building. So let's start first with the horizontal kit. I'd say that's the easiest one to build and then put on the robot. So you start with your base kit with the drive, as we finished in the previous step. Then you have all your components here from the horizontal kit. You've got the lid, you've got the terminator weapon blade, the mount, the hardware. This is called the bottom bump. This makes it drive very smooth. Your weapon motor, your weapon controller, and your front end. So the first thing you want to do is you want to take the two standoffs that we didn't use in the previous step, and you want to place them inside your front end, like so. Now this will pop right on into the chassis, like that. And now you want to secure it from the bottom with the two 632 screws from the previous step as well. So now that that's done, you have your base chassis. The next thing you want to do is mount your weapon motor to your lid. So to do that, you make sure this hole lines up on the left side, same as all the other one. This is for the FingerTech mini switch if using that. So you take these three M3 screws right here, and you attach the motor so the wires exit out the back. So the holes are kind of an offset pattern. They're not like a square or a circle pattern. They're two different measurements. So you can see it's kind of on an angle with the holes. They will line up perfectly for what you're doing. You line up the first hole, and you can leave it a little loose before you do the second one, because you can see it kind of, you can turn it and you get it lined up with the other holes, and then you put all four in. Once you get all four in, you can go ahead and tighten them all down, Get it nice and snug. You don't want it to fall off while it's spinning around. You can set this aside for now. We'll put the blade mount and everything else on in a few minutes. Now you go inside the robot. You want to do your electronics on the inside. So you take your lever clamps from before, you take the red wire from your speed controller, you put that in with the red, you do the same with the black, and it goes in with the black. These guys are going to end up tucking over here on the right hand side once we get to that point. Alright, this is the PWM cable. It connects to your receiver to tell the motor what to do. These are the leads from the ESC. These connect to the leads in the motor. Now on a horizontal, the direction of spinning usually doesn't matter too much for our purposes. So any way you plug them in is fine. If you want a particular direction and you go to turn it on and it spins the other direction, all you gotta do is take it apart, unplug 2 of them and swap them, and it will change directions. At this point, I'll show you how the receiver works. This is the receiver most of you will be using with the kit. It comes with the FSI4X. It's a 3-channel receiver made to go with that remote. It's very simple, easy to use. If you look at it, there's 4 sets of pins. You want to use, let's see if the camera can see them. You want to use these top 3 right here, 1, 2, and 3. It's 1, channel 2, channel 3. The signal goes on the inner pin. So channel 1 is the yellow wire from your drive speed controller, and it only has a signal wire. It's a 1 wire, so it goes in the signal slot only. The channel 2, you're going to run the 3 wire cable from the drive controller with the white wire on the inside, like that. I don't know if you can see it. That's a good view, I guess. And then your weapon speed controller, the white wire is the signal. That white wire goes towards the center of, or the middle of the receiver, just like that. And I like to tuck the receiver underneath this drive motor on the left, which is why we have that orientated flat. And with the horizontal, there's really nothing to worry about inside because there's just a ton of room. So you just kind of put the stuff in there. You don't have to tuck it behind anything. We're going to put the battery in right now. So before we do that, we want to make sure this plug is plugged in the charge jack on the bottom, because when this is plugged in, the robot is off. That way nothing will happen when we plug in the battery. So the battery plugs in to this JST lead off your charge jack. There's a corresponding plug on the battery. You match red to red, black to black when you plug it in. There you go. So I like to do this with the lever clamps towards the back, and then the battery goes in right there, nice and snug. And in the other versions of the kit, there's actually a lot of stuff in here, and so it all holds in nice and tight. So now you're going to put the lid on. You want to grab the 5 3/8 screws you had from the previous step, and we're going to put those in to put the lid on. So like I said, with this one, there's really not much to do on the inside. It doesn't have to be all specifically placed because there's plenty of room. So just kind of make sure the wires are tidy as you put the lid on. And there's a little channel right here where the wires will go through from the motor into the body, so they don't have anything pinching them. So there you go, nice and snug there. So we can go ahead and start putting the screws in. And you'll notice that the horizontal spinner has a much thicker top plate than the other 2 versions of the kit, because the weapon is mounted directly to the plate and you don't want it to break on a hard hit. We ran this same thickness plate on a previous version of this style robot for about, I think, 2 or 3 years, and we never once had it break. There's 5 screws that hold the lid on, same as the bottom, because they go in the corresponding location. There's one thing I forgot to do, which if you have the optional wheel guards, you'll need to put in the nuts for those before you put the lid on. So why don't we do that real quick here. I'll grab the hardware for those, and have it ready. And you take, this is a square nut, if you can see it right there. There's little slots right here in the front end. You just drop 2 of them in there, and you drop 2 of them in on the other side. All the wheel guard stuff is symmetrical, so you don't have to worry about which side you put it. So we'll get this lid screwed down again. We'll just leave those in there until it's time to put the wheel guards on, which will be right at the end. Get these nice and tight. Now all the screws, short of probably the lid screws, before you go in an actual tournament, you want to Loctite them, either like, probably the night before or even before that, because you don't want them to vibrate out. So like these 5 lid screws, I would not Loctite, because you take those on and off to access the battery and the parts inside. But you can Loctite the motor screws and all the screws along the bottom, and all the screws we're about to use, well, yeah, all the screws right here to attach the weapon assembly. So we're at weapon assembly right now. The way this works is this is a blade mount. This will go onto the motor. And then you put the blade on top of this, which mounts to the blade mount. And then the bottom bump here goes on top, and that's just to make it drive a lot better and a lot smoother. So there's 3 holes in the top of the motor. They're hard to see because the motor's black, but there's 3 holes, and there's 6 holes on the blade mount. Just so it lines up no matter how you click it in, because these little notches click into the vents on the motor to give it more strength when it takes hits, so it's not all transferring to the shaft or the screws. So before you put it on, eyeball where your screws are. There's one right there, so I'll know when I put this blade mount on and it clicks in. There's a screw hole right there. So you grab your 3 flat socket cap 12mm screws, you drop them in a little triangle pattern like so, and I get them down just a little bit snug, and then I go back around again and tighten them. So now they're in, hold on to the mount, get them nice and snug. Now these I would normally Loctite, that's if it was for a competition, but for just basic assembly it's okay. So now there's tabs on this motor that will line up, or on the mount to line up with the motor like that. It clicks in. You take your bottom bump on top, it'll line up with those holes, and then you grab these 3/8 screws and put them in. And same with everything else, you just kind of put them all in a little bit loose and then go back around and tighten them all. Makes the alignment a lot better and a lot easier. There you have it. I don't ever turn it on, obviously, and spin it, because it's very dangerous. That's what these are for. These are weapon safeties. So when it's not in use, you want to have this on, so that if it accidentally turns on or something, it doesn't hurt anybody. It'll stop, anything to stop it from spinning is fine. This is just the usual clamp everybody has. So now this is what it looks like. You have your horizontal spinner, and it can spin around, drive around, and go after people. Now if you want to do the wheel guards, if you have those, we put in the 2 pieces on each side up the front. There's 2 corresponding slots in the back. So you drop these in back there, and these slots. And then you take these are 7/16 inch screws. These wheel guards are symmetric, or the same, so you can use them on either side. Doesn't matter. What I like to do is put the screw through the top hole and then put it in the back side first. I find this to be pretty easy. And then you don't turn or crank real hard, you just kind of get it so they catch, and then you'll see it kind of go through, and then you feel some resistance, you're good. Because this is a squishy plastic TPU that we're using for the wheel guards, so it can absorb shock. So as a result, you don't want to crank it all the way down, because you'll just keep squeezing it forever. So you got the back end, the front. It's easy if you kind of poke it through like so, and then you find the hole where it goes in the chassis, and then just lightly screw it until it catches, and then do the same for this one. put on this side. There you have it. This is a fully functional robot with the wheel guards. Now, if we want to test it, we can't test the weapon because that's not safe, but you can take the blade off if you want to test the motor to make sure it's working. This is the safest way to test it. If you have a test box, obviously you can go spin it up, have a good time. But if you don't have one, if you're building at your kitchen table or in your garage, don't spin this up. But to make sure everything works, you can take the blade off and spin up the motor safely without worrying about it. So we can take all this off. Now we can power on the robot. So this is the remote right here. You just turn on the remote, and then you take that out. You hear the songs and the beeps. Now if you want to test the drive, you can keep it off the ground. You can see that forward, backward, and then we go left. You spin two different directions and the opposite that way. Everything's functioning there. Now if we want to test the weapon, you just take the left stick and you can go like this. And see it's turning and it spins up. So everything's fully functioning. So now you take your power switch here, plug it in to turn it off, look, nothing happens. You're good to go. Turn off your remote. And if you want, you can put the blade back on to store it away. I'm going to leave it off for now so we can move on to building the next version of the robot. But there you have it. The horizontal is built and ready to go. Welcome back. If you didn't leave, welcome here. We're going to move on to the lifter add-on for the Skizo kit now. So we're going to take this and turn it into this. And if you were just here for the horizontal portion, some of this may be a little redundant because it's going from scratch. In the lifter kit, you're going to have a front end. You're going to have your lifter arms. You're going to have your servo, which comes with a host of accessories. All you need out of the accessory bag is this one black Phillips head screw that attaches the servo arm to the gear. You'll have a bag of nut strip and hardware. This is for assembling the lifter scoop mechanism. This is the lifter scoop itself. This is your servo arm and your linkage. This is what we call the crossbar, which is kind of a loose term. It's the apparatus used to attach the linkage from the servo to the lifter assembly. And you'll have here the servo mounts. This is what attaches the servo to the chassis. That being said, let's go ahead and get started. The lifter is a little different in the way of building it because you have to turn it on before you get started. And the reason for that is in order to make sure the scoop, when it comes down nice and flat in the front, you need to make sure the servo is set at 0 when you put it in there, so when you have the stick down on your transmitter, it will sit down like this one does, right here. And put it. So if it wasn't set properly, when you turn on your remote, it may go to here. It may go to here because the servos know where they are, unlike a spinning motor that's just spinning or spinning this way or that way or not spinning at all. This one, you tell it to go to position B, it just lives there at all times. So that's why it's important you have it set at the proper 0 before you get started. So luckily we've done that math for you and figured out this is what you want it to be set at for 0. If you look right here, it's kind of coming right off over where the screw would be, or the corner of the servo body. And just put it up here too. It goes kind of like that. Just make sure you make a note of that so when you set yours, you're good. So the process for this, which I do before I even get started putting things together, is you can just plug this directly into your receiver, which if you were a part of the last step, you know where everything goes. If not, there's channel 1, 2, and 3 coming from there to there. The signal is the one closest to the inside of the receiver. So you're going to take the yellow wire from your drive speed controller, plug it into the inner pin. That's the signal for one motor. And then you take the 3-wire one with the white wire towards the inside of the body. You plug that in. That's your drive. Then your servo, you plug in the white wire in the same orientation as the other channel, and you put it into channel 3. Now what we're going to do here is we're going to power this up very briefly just to turn the servo. So we'll put in our battery. Note that the power switch is in, meaning the robot is off. So we're going to go ahead, put in the battery, turn on our remote right here, take the power switch out so it's on. You probably heard the servo make a little motion. So if you look at it, you can see it, and you can see it on the camera very good. So right now with the stick down, all the way down, you want to turn it off, because that way it's in your down position, so when you attach your arm later, you can make it match just like that when you do it. So go ahead and turn off your remote, turn off the robot, take your plugs out of your receiver for now. Now we can get started building the scoop assembly. We'll come back to the servo a little bit later. Now while it's very fast to change between modules once they're built, it does take a little while to build them the first time. So to build the lifter scoop assembly, you're going to need both arms. You need to keep this screw with your servo. I usually just kind of put it in here where it goes, just for safekeeping, because it's a unique screw that doesn't go with anything else. To do this step, you're going to need the scoop, the lifter arms, and then everything in this bag. And we're going to build something that looks just like this right here. You see how it kind of flops back and forth? That is how you want it to flow. So we're going to build all of it real quick. So in this bag you have all your nut strip and the required hardware. You got 3 of this smaller 4-hole one, 1 of the small 2-hole, and 2 of the big ones with 2 holes. These are called 2x1 632s, 2x1 440s, and 4x4 440s, because it has 4 holes, 4 holes. This one has 2 holes and 1 hole. You got a selection of screws here. Some of them are 632 pitch. Those are for these larger ones. So for that one you're going to have 4 1/4 inches and 2 1/2 inches. Now for these other smaller ones, you're going to have 7 of the smaller 1/4 inch ones, and you're going to have 8 of the 1/2 inch. So when we start doing this, remember that everything goes in loose to start, and then you're going to tighten it down later once all the alignment's good. So the first thing you do is you take one of these 4-piece ones. You're going to line it up not with the hole furthest down, but with this second hole here, the bottom hole, but not this bottom hole, lined up with this hole. So it's going to look like this when we're done. So you see the very bottom one comes through from the scoop, and then this is the one that comes through from the side. So you take your longer screws, because they're going through the arms, and you get that started. You can take your driver here and leave them loose. You know, don't snug them down, but have them pretty close, right? It can still move, but it's where it's going to live for the most part. Then put the other one through the other hole, and then do the same on the other lifter arm, but make sure to note the orientation, because these go on the inside. So it's the same thing. Mirror flip of the other one. Alright, you got that done. Now, for the next part, you have to note which is going to be your right hand one and your left hand one. Because if you look at the way this plate goes, the holes are lined up like so. And there's a reason for that, which has to do with the travel for the lifter arms. So on what's your right hand arm, you want to use the smaller one. So it lines up, it has 2 holes right here. Now these arms are interchangeable. You can use them on either side, but once you've determined which one's the right side, you need to use the 2-hole one on this side. And you put another one of these guys in. Alright, now we need to put the 4-hole one on this side. Now if you look at how it looks on this servo, you'll see that you put the furthest one out to match this hole right here, the furthest up hole. And you grab your last longer one, Pop that in. And so if you look at it after you've done this, you can see on this arm there's an extra hole here, because if this arm was for the other side, it would line up with this. And same reason there's a hole here, which would line up with this one. So the arms are interchangeable for the purpose of the arms, but there is a right and a left once it's assembled. Now you want to loosely apply the lifter arms plate, is what I've named this. This uses the 1/4" screws. It doesn't really matter what order you attach it in, just leave them loose and we'll tighten it once we're done. So that goes in. That goes in. And there you go. So loosely looks, starting to look like this guy, just a little bit. Now we need to put the scoop on. This scoop was the same way as the other stuff. And if you look at the bottom of this one, you can see that the scoop holes come in right here at the bottom piece, right? So you want to take one of the smaller screws here, run it through there, and this screw here on this side of it is going to attach to this hole right here at the front. This one right there. And again, leave them loose. We'll tighten them in a little bit here. And this one lines up the same way, so all you really have to do is just kind of see where the holes line up, because it'll all be orientated properly once you get this far. There you have it. This looks a whole lot like this now, doesn't it? So now we've got to attach it to the lid. There is a left and right to the lid because of the access port if you're using the mini power switch. So this goes on the left hand side. This is the top. The easiest way to build it is upside down, because these pieces here go underneath if you look at how this one is built. The reason for that is it keeps the arms concealed, so if someone's hitting you, they can't hit your arms. If they were on top, the arms would be up here and they could get hit. So it makes it a little more durable. So you're going to take your 632 1/4" screw here, and you're going to pop it through the top here, and then you're going to attach one of these guys. It doesn't matter how you screw them on, they can flip around, but they only go on one way. And leave these loose as well. That's kind of the theme for building the lifter scoop and lid. And you can see this takes a little while to build initially, but once it's built, it comes off just as fast as a horizontal lid. It's very, very quick. So these are on. Now this is the point at which you flip it over. So see, this is on the left. So if there was a power switch in here, like there is in this one here, you want to keep the hole right there so it lines up. So now you can flip it over, and you flip over your scoop. The scoop lives on the outside. I made these a little too tight, so I'm going to loosen them up a little bit before I get going here. Yeah, these are still nice and loose. So you're going to want to lay this upside down, and then your lifter's assembly is going to pop in just like that. You take your 632 1/2" screws, it runs through the hole right here in the back of the arm, you can see it, and then it's going to thread into this middle slot on here. Now you don't want to crank these all the way, because this is going to move. So I do recommend Loctite on these for final assembly, but for the point of the video we're not going to put the Loctite on. So you get them mostly tight, but don't go crazy on them, because you want it to be able to move around. And it's something I usually check between rounds. Anything that moves around, I check it to see if it's come too loose. So you can see everything's good here now. It moves around just fine. Now we've got to tighten it down. So you want to have the sides of these arms pretty well flush with the scoop edge, or maybe just a little bit inset. So you're going to want to start tightening from the side, and you don't crank them either, you just kind of get them snug now. And the reason for this is if you go crazy with this many screws and attachments, if you tighten them like just one by one from the beginning, they're going to be out of alignment, and then it's not going to fit good. There's even a chance it doesn't fit good when I do it right now. But so those are snug. So now I'm going to snug down these top ones here. I'm going to go back through and tighten my scoop. And these I'm putting all the way tight right now. And again, these are all things you would Loctite if doing a final assembly before a tournament, because you don't want them to come loose from vibrations. Now I'm going to hit these ones on the side just a little bit more, make sure they're nice and snug, because if they happen to be sticking out, they could get caught when it's going back and forth. There is a clearance involved in there to allow them to move around, but if they stick out too much, they could hit the side, and that's not a happy day. Now, next step is we're going to put on the crossbar, as we call it, and then we'll put on the linkage as well. So I like to take this screw out of the arm that goes on the servo, because it's easier to put this on when it's in the robot. And this again is another one of those unique screws that doesn't go anywhere else. So I put it back in the arm when I'm not using it, just so it stays with its home. You can leave it like that, and you won't lose it that way. So this is a very important part of the lifter. It's also probably the most expensive tiny little screws you'll ever buy. But they make it so we can do it without having a crossbar all the way across, which makes it go up and down and have a lot more free flowing as it comes in over the front end. So the easiest way to do this, if you happen to have two of the drivers, is super easy. What I like to do, again, Loctite these for assembly, is you take this 1/8 inch flange head screw and you put it in the little crossbar here. And the flange on here will actually keep this linkage from coming off while you're using it. So then you put the linkage through like that. You line it up with the hole that's right in front of the hole in the lifter arm plate. So there's a big fat hole there. That's to allow the top piece of this to move around when you go up and down. You can kind of see it in the one that's already built over here. You see how it's right here. So as it moves back and forth, going up and down, it can kind of come up a little higher. So that's why that clearance is there. So you will take, I like to put one through the hole on the other side, because remember these are interchangeable, so the hole exists on both sides. You put it through there, and then you grab the other side of it. And it's so easy if you have two. That's what I recommend, because then you can just do that. You get them nice and tight. It's not going anywhere. The linkage is obviously a little bigger, so it can move freely. And there you have it. You have your lifter scoop, and you see it moves very, very, very freely, which is what you want, because it wants to go up and down a lot. We'll set that aside for a second. Now we're going to do the servo mounts and the servo and the linkage. So these mount with 4 screws from the bottom. If you can see the holes, there is a hole here, there's a hole here, and there's two corresponding holes back here as well. These are the ones you use for the lifter assembly. The other holes are for the vertical spinner. And you do all this before you put the front end on. I know on the horizontal we did the front end first. Not the best order for the lifter. It's a lot easier to do this because you're actually putting stuff inside. So the way I like to do this is I will loosely, well, first thing you want to do before anything, you want to put this arm on. And remember, it wants to look just like this. That's the orientation you want. So we'll put this on. I think that is pretty well right there. I think it needs to be one tooth further. Let's see how it looks. There's 25 teeth, so each movement's like 4%. So no, this one's going to be happy right there. All right, we'll set our example servo aside. Take your screw here. This is a Phillips head screw. There's not a lot of Phillips head screws in robot kits, but there is for certain things. So you screw this in. Now to make sure it gets real tight, again, this is another Loctite situation once you're doing your final assembly. I like to put a finger underneath the arm to provide resistance, and then tighten down real hard. Now if it moves around a little bit while you're doing this, it's okay, as long as you already have the arm on. Because remember, the servo remembers where it is, and you put it to what your robot will think is 0 before we did this. So when you turn the robot back on, it's going to go right back to there, which will be scooped down. So we've got, it's also, technically it's called the servo horn, but everybody calls it an arm. So we've got that on. Now we can put the servo mounts on. If you look, they have a threaded portion that goes behind these 2 holes right here. And just like the last portion, we'll put them on a little loose, get it the way we want it, and then crank them down. So that's on there. These could actually slide out if they're not kind of tight. So I get them kind of tight. Now when you go to put it in, you'll notice that the holes in the front are a different spacing than the holes in the back. Now that is just for orientation of the servo, to accommodate having the holes and everything for the horizontal and the vertical in here. There's 5 different mounting holes, so all are fine. The front one here, this one, is going to line up with this hole, which is this one on the bottom. Alright, so if you look on the bottom, you can see where the holes are kind of lining up. I like to push it past, make sure there's no more holes, to confirm that's the first hole, and then I will hold it in place and put a screw in. Again, a little bit loose. And then you're kind of good to go. After that, grab your next screw. This can only line up with 1 hole now, so line it up with the 1 hole, and as you do that, it will consequently line up the other section with the holes they use. Alright, the servo I like to sit as far forward as possible. That's why I leave it loose, so I can push it forward with my hand, and then I tighten everything down. So now that that's tight, you can tighten it down on the mounts on the actual servo. And that's kind of the cool part about this little setup with the flexible body. You can move it out of the way to tighten your screws. They tighten these, and on this side, you can kind of come at an angle. You can take it all the way out again if you want to, but you don't have to. So this one you can actually come underneath to hit the bottom one. Easier if there's no wheels on it. But let me take this wheel off, make it a lot easier. So I like to take the wheels off like this. You can peel it back and find out where the set screw is, and then you don't have to take the twist ring off the top. So just do that. If you don't need your wrench, you can actually just leave it in there until you put it back on. Now I'm kind of lazy, don't like to take it apart, so I will shove it through this way, and I can get to it like that, if you can see it real good, and you can tighten it down without taking anything apart. Then the top one, kind of hit it like that, or sometimes I'll just pull the whole side back, but there's enough give here to get it nice and tight. So that's good. You put the wheel back on. Now look at that. It conveniently already has the wrench in it. Do that and pull it out. So now we're kind of ready for assembly. So what we're going to do here, make sure your power switch is in the bottom. We need to pull the red power wire out of here. There's multiple ways to do it. You can just cut the wire if you want, or if you want to be fancy, it may take a couple tries, but sometimes you can put a little pick in here and get the tab to lift up if you're lucky, and then you can pull it out, and it makes it go in the clamps a little better because it has a rigid thing to clamp onto. You just got to get it just right to get it to yank out. There it is. You have the pin. You're going to take this, and the red wire goes in with your power. There is no black wire for the servo because it gets its ground from the receiver. So you want to take your receiver here, pop it into place like so. Alright, so when you do this, you need, once you have everything in here, this doesn't look like the best arrangement right now, but it will shortly. You want to go ahead and take your channel 1 like we did earlier and put it in to your receiver on the inside pin in channel 1. Next one, white wire to the inside. There you go. And then what's left of your connector from the servo goes into channel 3. And the reason we take that power wire out is this receiver provides 5 volts of power, whereas this provides the full 8.4 volts of a 2S LiPo. Now, or a 9-volt battery if you use that. If you use a 3S battery in here, you need to use a voltage regulator because these servos are not designed to run on 3S. So if you want to run 3S to make it drive faster, you'll need to pick up a 9-volt regulator to cap the voltage going to the servo at 9 volts. Now that this is done, we're going to put the front end on just so we can handle that speed controller orientation better. So just like in the horizontal one, you pop your standoffs in you had left over from the first step building the base. You can slot them into place, grab your little 1/4" screws here from the bottom and screw them in. Alright, there you have it. It looks kind of like a robot now. For the meantime, I'm going to take out this little screw for the servo arm and keep this somewhere safe right here on the fancy little baseball card thing. Alright, so now when you put this together, the drive ESC will sit nicely right down in there. And these wires can go over the top of here just fine. You want to get the connector right there shoved in like that. And then you take your battery, again make sure power's off when you do this. Plug in your battery, and like I mentioned in the horizontal, the lifter and the vertical actually have a lot of stuff inside, so the way you pack it is more important. You want to keep stuff out of this area because this arm moves up and down. The battery will pop in right here. It kind of sits right in front of the beginning of the gearbox. And at this point, sometimes you can, if you have the little bread tie or a zip tie, whatever you want to use, it's nice to kind of tidy up the servo wire because they're very long. I don't need them to be that long for this application. But for the purpose of right now, we can just coil them up and push them in. So this is what it's going to look like when you have all your wires in. These 2 wires here can go on the top, on the side, doesn't matter, as long as they're out of the way. And you just want to make sure there's enough room on this side for the lid to come down, because the arms are actually going to sit in there. But as long as you're not above the servo, you're fine. If you have the wheel guards and you want to put them on, you need to make sure you drop in the nuts just like on the horizontal, right in these little slots right here. You put 2 in each slot and they'll kind of get them down to the bottom. So now we put the lid on. The lid goes like this, and you grab your 5 screws that you had left over from the first step. These little 3/8 screws. And again, these are 3/8 inch long because it made it so one set of hardware can build all 3 versions. You really only need them this long for the horizontal because it's got a thick lid. If you're looking to save a little weight to do some mods, the lifter and the vertical can actually do just fine with 1/4" screws. So you can save a little bit of weight there if you need to. Now this lifter, along with the horizontal and the vertical, there's also a range of upgrades you can do over time as you have fought them more and gain some skill and have some preferences or some ideas you want to try. So all of them can be upgraded from 2S to 3S, which makes the drive faster on all of them. On the flipper, because you have to use the voltage regulator, it makes it flip a little bit harder, but also drive real fast. And on the horizontal and the vertical, it drives faster and spins faster with no need for a regulator. In the case of the lifter, there's upgraded servos you can put in. Like this is a 25 kg. We also have a 45 kg. We don't put it in the kit because it's rather expensive and it's only for people that really want to make it a flipper instead of a lifter. The ones that we run are fully on 3S with the big servo, and they do a lot of full 360 flips in the air. It's really nice to see. But to keep the cost of the kit reasonable, We put in the 25 kg, which you can lift people up and probably flip them over too, just maybe not as aggressively. So now we need to attach the linkage to the arm. So I usually start this with my hand, if I can, or at least get it in place, and then I grab a driver and get it started. Now this is also one that moves around, so you can't really see it, can you? And that's better. So as you screw this in, this isn't actually the right screwdriver for it, but it's close enough for this job. So you get it going in there. And this one you can make it pretty tight. You don't want to go mega tight, but you can make it snug because it'll move up and down. So see, this is where you want it to land, right there. So the power switch is out and it's flat, it's right there. Now there is something else included in your kit that's kind of weird. It's this little peg looking thing. This is called like a wheelie bar, a wheelie post. When you put in the really aggressive servos, they can flip, they'll go so fast they might pop a wheelie when they drive, which is no good if you're a flipper and you want to have a ground game. So you want to, if you put this on the bottom, it can't do that. And it also makes it flip so much harder. So if you want to do that, what you do is you take one of the 3/8 screws out of the top and you swap it with one of the 1/4 inchers from the bottom. Because again, the 3/8 are only needed for the lid on the thicker lid of the horizontal spinner, and they aren't necessary on the lifter per se. So, but to put this on, you can take that 3/8 from the top, move it to the bottom, you pop it through the hole, and you tighten this guy on. Now you'll notice it has a bit of a slant to it. You want the taller part, I don't know if you can see it, but you want the taller part to be towards the back. And the reason being is it'll sit much flatter on the ground based on the way the robot sits. So what happens now is if it tries to pop a wheelie, it can't go back. Or if it flips real hard, it has more support to flip over your opponent. So it flips a lot better. It's not necessary for operation, but it's there in case you want to use it. Oh, let's put on the wheel guards. Let's do that. All right, if you saw this in this previous step, you get to see it again, because not everybody watched that step. So you drop in your nuts in the slots in the back, same way you did in the front. You take one of these 7/16 inch screws, you take your wheel guard, you pop it through. I like to do the rear first and the top hole, and you just pop it right in where it goes, and just do it a little slowly, not a lot of pressure, and you'll see it catch. Then when it gets pretty snug, you'll see a little bit of indentation. It's hard to see in the camera, but a little bit of indentation on there. That's when you're good. You don't need to crank them because they'll just squish it to no end if you just crank them. Then on the front, same process as the back. Pop it through the top hole, get in there, it'll catch itself up and snug it down. Here we go. Do the same thing for this side. All right, there you have it. This looks more like, you know, this one. And so to test it, you want to make sure your scoop is like right about the bottom, you know, right towards the bottom of the where you're competing. So it's going to change from arena to arena. So I usually use the trim on the remote, if you haven't discussed that yet, but on your remote there's a trim button here and a trim button here. For this purpose, we're only using the up and down one. And we'll see if we even need to use it. So we'll turn on the remote, turn on the robot, and you see that, hi, how you guys doing? So this one's actually fine because we set it to perfect 0. But so if we move the trim all the way up, you'll see how it's kind of lifted up. The trim adjusts like where your 0 is. It's like an offset. You clearly don't want that to be the bottom because you're never going to flip anybody. And you also don't want it to be too low because you'll see it gets too low. See if this one will do it. It doesn't really do it on this one. It's set kind of just right. If it's set way too low, what will happen is this will go down and the front body, the body will lift up. You don't want to fight that way. A, people can get under you a lot easier, and B, it puts unnecessary stress on your servo because it's pushing against itself the whole time, and it's likely to break a lot sooner. So you'll hear a long beep in the middle, like that. Now you're in the middle. It's nice and ready to go. So there you have it. You now have yourself a lifter ready to fly. So there you go. We can drive it around. It's a flipper. It's not as worrisome as the spinners are. Let's see if we can flip its buddy. Let's see. Ah, there you go. Got yourself a flipper. All right, that's it for the flipper. We'll move on to the vertical for the next portion and finish off all 3 of the modules. All right, welcome back. If you've made it this far, congratulations. We're now on the 3rd weapon module and final one for now until more modules come out. If you look at the screen here, you can see there's a whole lot of parts on the vertical module. We are building this guy here. It's got an AR600 blade. There's also an option to upgrade to a titanium blade that's twice as thick. So let's get started. You'll notice on this one it has larger wheels than the other ones. That is so it can drive upside down. The horizontal drives upside down with the 2-inch wheels. The lifter can self-right itself, so it's fine. The vertical, on the other hand, because of the diameter of the blade, wasn't able to drive upside down on the smaller wheels. So it went with the larger wheels on the vertical. They're included in the add-on kit, so if you have the 2-inch wheels from a previous kit, you can just take those off and then put on these larger 2.5-inch wheels, which we'll set aside for now. You'll see there's a lot of stuff here in front of you to build this kit. Let me get this as an example. You can look at the finished one here. These are your uprights. These are what holds the weapon stack together. This here is the weapon stack. Then you have the weapon motor here. The controller for the weapon motor. This is the hub. This is all the hardware to attach the weapon stack together. These are the plates that hold the bearings in to make it spin. This is the weapon shaft along with the bearings that go inside. This bearing goes on the motor inside the robot, and it goes inside the side of the wall like so. And that allows the other end of the weapon shaft, or the weapon motor shaft, to be supported very well. This piece here is just a protector to keep stuff from hitting the motor on the inside, because this motor is inside the robot and the outside of it spins so very quickly. You don't want it to hit anything inside. And here is this is the AR600 disc. I don't have the titanium one on the desk right now, but it's roughly twice as thick. Goes from 3 millimeters to 1/4 inch, and the weight is almost comparable. So in terms of inertia in the weapon, it's probably about the same. In terms of the hitting experience, this thinner blade will have more of a slicing effect, whereas the thicker titanium blade is more of like a thud, like a hammer effect to throw people. Whereas this you'll more frequently get cut through something. So it depends what kind of damage you want to do. You can upgrade the titanium blade. It comes with a different hub to accommodate the different weapon size. Everything else is the same. You'll also notice there are 2 different front ends that come with this kit. This is the fork front ends, because forks are popular. So this is to get under your opponent before you hit them, so they go flying a lot higher. There's also the standard front end here, which comes out the same distance as the other front ends. They're both included with the kit. You can use whichever is your preference. We have the same base kit we've started with for all of the modules so far. So the first thing, what should we do first in here? I think we should build the weapon stack. And again, this is very much a Loctite situation when you build the weapon stack. So let's dump out all the hardware. These 4 standoffs will go inside, and you're going to use 8 1/4-inch screws that are going to go with these retainers on the back. And then these 8 plastite screws will be used later. What you want to do, pop these standoffs in here, like so. And then you can put the first plate on this side. So you'll put the a little cap on there, grab your 632 1/4" screw here, and again, Loctite these all day long. You may notice I took a few screws out of frame earlier. I'll put them back in frame. These are the screws that mount the motor inside the chassis. They aren't really relevant to these steps. So once you've got the first side of it done, this will be the left side where it has the hub on the outside. Then you can take your bearings that are conveniently shipped on the shaft. Take one of your bearings, drop them in there. Then you can take the other bearing if you want and set it there. Now you're going to take the other side of the hub, press it on, drop your last bearing on there, and now you're going to put the blade on. There is an orientation to the blade because you want them to spin up. So this is the hitting edge. You want to hit like this. So if you look at the already assembled one here, you can see it comes around and it hits like that when it's driving. And by the way the belt placement is, this needs to be on the right side of your hub in that orientation. So this will end up being the right side. That's why there's extra space. The blade will slot right on to the standoffs here, like so. Then you put the cap on, and this is what holds your bearings in. Instead of just screwing the blade on, this holds the bearings in. I think it's a tie between the lifter and the vertical as to which one takes the longest for the initial assembly. After they're put together, the swapping of the modules between rounds is very easy across all of them. There's not much to it. So now our weapon stack is built. We're going to set this aside for a while. We don't need that for the moment. Now we're going to work on the weapon motor. These uprights are interchangeable left and right. You've got 4 holes in them here to mount the motor, holes top and bottom for the plastites to hold them into the chassis, and then this is where the weapon shaft goes through, and these little notches here are actually where the front ends click into place to give it a little more stability when you're fighting. Because if you notice, the other versions of the kit have a continuous front end. This one can't because it's got a blade spinning on the front. So this way it ties everything together real nice to give you a nice sturdy chassis. These are M3 10mm screws right here. We're going to take these and we're going to start mounting the motor. You want the wires to come out the back side. So these wires will exit out the back. So take your screw, pop it through, line it up with the appropriate hole on the base of the motor, and screw it in. And you'll note that the motor in the vertical and the motor in the horizontal are not the same. It's because of the diameter of the weapons. So the weapon blade on the horizontal is a 6-inch diameter, and this one's 70mm, which is a little less than 3 inches. So in order to get the same tip speed, a higher kV motor is required for the vertical. You don't want to put a higher kV motor onto the horizontal because it will just go too fast. It's like an 1100 on a 3S is about 240 something miles an hour tip speed, which is fine. We want to take this bearing here, put it over the shaft, then take this belt. This is the belt that's going to spin the weapon stack. Take this out. You're going to flip it over, so you're actually putting the smooth side onto the motor. And the reason being is this is not toothed, and this hub is not toothed. So you can use a belt just fine, but use the smooth side. So pop this thing on. But before I do that, let's show you how this works. So in the bottom of the chassis, you've got lots of holes, right? This circle here is the clearance for the horizontal motor. These little holes are what we mounted the lifter with. Now you've got these 4 holes here, which is where the vertical uprights screw in, and you got these 4 slots, which is where it clicks into place. That's why you see these little kind of notches on the bottom. That's to make sure the alignment's good when you put it in. So it'll click right in. So when you hold it on the bottom, when you look and see, they pop through the bottom a little bit right there. And then the front, it lines up right with the end of the base. And that's what these 8 screws here are for. There's 4 on the bottom, and then there'll be 4 on the top later. So grab yourself a really small Phillips head screwdriver. And I do like to put this together in one shot if I can. It's kind of like a challenge, because you got to hold it together real good. If I get it all clicked in here, I'll hold it with my fingers like so. Put some pressure on it. If you look at the bottom, you can't really probably see it on the camera, but the screw holes will line up with the holes in the bottom of the chassis. So there's no real question over which one it goes into. See, the other one fell out. It's okay. We'll pop it back in a second. So the one thing, make sure your belt is on before you put the other side on. Otherwise, you have to take the other side off to get the belt on. You don't have to put the bearing in at this point, but you can, because it's easy. And it'll make it line up real nice. So now, you can put in the other side. So, you grab screws here. Grab another one. These will get nice and snug. They are plastites going into a plastic material, it's UH&W, so they'll grab pretty good. Now, once they're in, you'll actually be able to feel the notches that come through to keep it aligned. That's why it's pretty steady right now. You'll put the top on later. Now that we have that done, we can go ahead and put in the weapon. Let's have fun with that. So to do that, it's pretty simple. You take the weapon stack here, you loop it through the belt. There's a little place where the belt sits, and you pull it through with here, pop in your shaft, which is a 2-inch bolt, and then you put it on. And then you tighten it down. You don't have to tighten it down all the way, it's a lock nut. You just want to tighten it down so it gets into the nylon portion of it to keep it from coming off. A little loose here is fine, because you want it to be able to spin freely. Don't worry about the alignment of the belt too much there, because it'll take care of itself as it spins. Now we can put on the front end. As in the previous steps, you'll take your standoffs that you had from the first step, pop them in. Now these, because it's flexible, you pull it out, and then you line it up and kind of pop it into place like so. So it's nice and snug. Grab your wrench or your driver, and then it'll line up with the bottom. And then do the same thing for the left side. You can kind of slide it out once you pop it in. Get this to line up right there, pop it into place, and then grab the proper driver, and oh, my standoff came out. Pop your standoff back in. There you have it. Looking like ready to roll here, huh? So this one's a little more forgiving than the lifter is, but you do need to grab your weapon speed controller here. Red goes to red, like in the previous steps. Black goes to black. Now, I don't have my test box in here right now because we're loading out for a big event tomorrow. It's in the truck. I'm not able to spin this up on the camera for you, but once you power it up and you find a safe place to test it, or you can power it up before you put the weapon on. This needs to spin up. Unlike the horizontal, there is a particular way it needs to spin. So this needs to spin coming up like that. So if you plug it in to your speed controller and it spins the wrong way, but it's spinning forward, all you do is swap 2 wires. So say it was plugged in like this. You get all 3 of your wires plugged in here. It spins the wrong way. Doesn't matter which 2, just grab 2 of them. I'm going to grab the red and the black here, and then just put them in, swap them in slots. It will now spin the other direction. It's that easy. The reason I have this protector right here is because if wires get underneath in here, it'll stop it from turning in the middle of a fight, and that's not good. So this one actually goes underneath, if you can see it. It's kind of, this part here goes underneath the motor wires. And then on this part here, this clicks in on the bearing side of the upright. So just be careful with your wires as you put it in. Make sure you don't get in the way of anything. And it will just kind of pop into place. It holds in with tension. It's not like a load bearing piece. Now you can put your receiver in. If you're using the standard receiver, it's the same as I said before. If you're using your own, like an FS2A or one of the smaller ones, you probably already know how to do it if you're using that. But you put the yellow wire into the signal slot on channel 1. If you weren't here for the previous two modules, this is channel 1 on down here, channel 2, channel 3. The signal pin is the one closest to the middle inside of the receiver. So you're going to put this yellow one for the drive and the signal on channel 1. The 3-wire one you'll put in channel 2 with the white wire towards the inside. And for your weapon controller, same kind of orientation, channel 3, white wire to the inside. And this will pop right in here. Same place it goes in all the other versions. And now you really have a lot more freedom with how you put your stuff in this one, so you can kind of put the stuff basically however you want, because it's going to be fine. There's nothing interferes with anything in this one. So grab your battery. Whether you're using 2S or 3S, it goes on the same place. Make sure that it's turned off before you plug in the battery so nothing weird happens. Red to red, black to black when you plug it in. So the way I like to do it is I put these back here, and the battery drops in right there. It also helps hold that protector on. And there's a nice little area here to put your weapon ESC and your wires, so they're not in the way of anything that turns. Now we can go ahead and put the lid on. Now again, there is a left and a right because of the hole for the mini power switch. So you pop this guy in. Go grab your 3/8" screws from when you built the base part of the kit. You screw these in. Now you'll notice I did not do the wheel guards on this one. Depending on your configuration, it really doesn't always make weight. You may have to do some weight reduction to use them, but there are accommodations here for the wheel guards just like on all the other ones. So if you find a way that it makes weight and you like the wheel guards better than whatever weight you took out, then more power to you. There is a picture right behind me on the screen here of this unit with wheel guards. I don't often run them because I usually use a bigger battery, and that takes up my weight. That's where I like to use my weight. This also has an upgrade path, as with the other ones. The titanium blade is an upgrade, and also you can upgrade the weapon motor to a higher kV so it spins even faster. I don't recommend it on day one. I only recommend that if you kind of know what you're doing already, because it'll be a little too fast for a beginner. So now this is what's known as the belt protector. It doesn't really protect the belt, it's just what we call it. So what this does is this is going to go on right here. It's mainly to tie these two together, so a little more stability. It also kind of acts as a belt guide to keep the belt from turning. I have it upside down. There you go, that's better. So you notice there's a little path here for the belt to go. So if it does get a little wonky, if it starts moving around, it might hit this and center itself back up. So this goes in just like the bottom did. This will line up with the pre-drilled holes for you. They're a little undersized on purpose, so these can thread in and grab real nice. And because this one can spin around, I usually crisscross it. So I do one corner, then the opposite corner. And before you tighten down, make sure the other two holes line up real good. Otherwise, you'll have to loosen it and do it again. If you notice, it's still flying in the air with no wheels. So we'll put the wheels on in a second. And if you're not going to run wheel guards, I have a little pro tip for you on how to protect your wheel hubs a little better. So this kit uses the lightweight wheel hubs. So if they get a really heavy hit on this side, they could pop the ring that holds it in. Most people have this on the outside because they like to put the hub on and put the wheel on. I like to put the wheels on off the robot, and I find it easier to put it on and off. So what you're going to do here is you're going to take your driver, look at the back, find out where this little square nut is, and that's where the set screw is. So you get it to where it lines up with it. It might take a second to find it here. There it is, I got it. So if you put them on backwards, per se, this side will be facing out, which means if you take a hit over here, it doesn't kill the ring, and then your wheel doesn't come off. So it'll get a little bit more durability out of it if you do it that way. So we'll take this here, pop it on, and there you go, that's one wheel. We can do the other one real quick here. Oh yeah. So make sure you find the flat part of the shaft, put it on there like that. There you have it. Look at that. You have ourselves a vertical spinner. And it looks a lot like this vertical spinner. They're buddies. Well, I appreciate you watching the video. I hope you enjoy the kit. I spent a lot of time making this to try and make a modular kit that's beginner friendly yet has a path for upgrades and is durable in the level of competition we see today in the tournaments. So this is built in today's design language, and today is 2025 November, so if you're watching this video in 2027, there may be a whole new design language by then. But as of today, this is a very durable kit. It can hold its own in a fight, and if you're a beginner, you'll get a lot of good practice with it. It won't blow up real fast. It's made to be durable. It's based on a robot that's super duper durable. So have some fun. You can buy all the add-ons individually instead of having to buy a whole new robot each time. So when you buy the robot, you will pick a weapon module, whether it be the lifter or the horizontal. You pick which one you want to start with, and you will have that from the get-go. And if you want to change it from one to the other, as we saw throughout the video, it's very easy to swap modules. So the modules are available by themselves. So you don't have to buy a new robot, buy a whole new drivetrain, all that stuff. If you want to change from a lifter to a horizontal, you just buy the horizontal add-on, pop it on, keep going. You can change in between rounds. You can mess with your opponent's heads. So if they think they're fighting a horizontal, all of a sudden a vertical comes out, and it really gives you kind of a competitive edge. But thank you for watching. That wraps it up for now, and have fun fighting your robots.